In this video, I'm going to show you how to build a shimmer animation for when you're loading your list items. And this is difficult to describe in words, so let's go take a look at a demo. So what does this shimmer thing look like, you might ask? Well, if you have a list of data, it's very common these days to show this kind of shimmering animation. So if I click on chicken, for example, you can see that there we go. We get kind of a fake kind of recipe card showing for a brief amount of time, and it looks like it's sort of like glowing or shimmering. And you could do this horizontally, you could do it vertically, or in my case, I've done it kind of from one corner to the other. I think that going from corner to corner looks the best personally, but you could go from top to bottom, from left to right, whatever you prefer. In this video, I'm going to show you how this works so that you can really design any kind of shimmer that you want. So like I said, I'm going to be showing you the very detailed way, the very detailed mechanism of how this actually works, so that it won't matter what kind of shimmer that you want to build, you'll be able to. So we're going to start with like a demo of how the gradient system works, what we're trying to achieve exactly, and then work on animating that thing kind of frame by frame. So if you came to this video and you just wanted to watch me go code something up for 5 to 10 minutes and just kind of slap it in and not really understand how it works, you've come to the wrong video. In this video, I'm going to be showing you everything you need to know so that it will empower you to be able to build things on your own. I don't really care if you can just, copy what I'm doing. You might as well just go look at the code if you're going to do that. If you're here, if you're watching the video, I'm expecting that you're here to learn. So I'm going to be showing you everything you need so that you can build your own animations. If you do just want to, copy the code, there's nothing wrong with that. And you just want to get this shimmer thing into your project, you don't care about learning, just go to the source code. There's a link down below to the source code for this project. It's free. Just go copy the required composables to get the shimmer animation and put it in your project and be on your way. But if you're going to do that, don't forget to leave a like and some engagement down below. Tell me that you appreciate this shimmer animation that I built for you. And again, don't forget that like. So at this point, we have no knowledge. We don't really know how to start. So let me first give you a brief example to give you an idea of how we could maybe accomplish what we're trying to accomplish. So let's go into recipe list fragment, and I need to increase my font size. So hang on a second. Let's crank this all the way up to like 52, something crazy. So that should give you a better view. Now what I'm going to do is get rid of this pulsing demo from the previous video. And I'm also going to get rid of the animated heart stuff. That was all from the previous video. Currently we have this commented out, which is actually our list of data. So I'll leave that commented out. Down below, I'm going to create a brand new composable and just show you, well, you know what? I'm just going to show you. So just hang on. This is going to help you understand what we're going to be trying to accomplish. So just write at composable and create a new composable function. I'll call this gradient demo. And I know that you're completely confused. You have no idea. Why did I even call it gradient demo? Don't worry. Just hang on. I need to show you some kind of an example, so to give you some kind of an idea before we start. So call it gradient demo, and let's specify some colors. Again, I don't expect you to know what the hell I'm doing right now, so just kind of follow along. So we're going to do 3 colors. One will be blue, one will be red, and then we're going to get that blue color one more time and get that color import. So Alt Enter on there and get that import. So I'm creating a gradient. Just kind of keep in mind I'm creating some kind of a gradient thing. Now I'm going to create a brush. We'll be using the brush to paint on this gradient. So I'm going to be using a function inside a companion object called linear gradient. So if I open this up, it gives me an import. So this is part of the brush class. So if I hold down Control and click on this, it is part of it's an extension, or it's a function inside the companion object of the brush.kt class. So linear gradient, this takes a couple arguments. One is the colors, the start, the end, and the tile mode. We just care about the colors, which I've specified up above. Now, where does this start position? This is an offset. Again, I don't expect you to understand this. I'm going to be doing diagrams, and I'm going to explain all of this to you. So just copy this out for now. It's just meant to give you some kind of an idea. So offset, and let's do, I don't know, 200 float and 200 float. Maybe start this one. Let's actually start this one at 200. And then end it at 400. So 200, 200, 400, 400. Pretty straightforward. Now just add let's do a surface. And inside the surface, we'll do shape equals material theme.shapes.small. Probably need to get some imports, getting all those. Now inside of our surface, I need to add a spacer. And we're almost at the example, so just hang on. I know you're confused and you're frustrated because you're just randomly copying stuff and you have no idea why. So just hang on. We're almost done. So background and then do brush equals the brush. Okay, so now let's use this gradient. So let's go up to the top here, add this gradient demo, and let's just see what this thing looks like. So I'm gonna run the app and we're gonna see what this looks like. All right, so what is this thing? Well, we've created a linear gradient. A linear gradient goes from basically corner to corner. So like this top left corner to the bottom corner. And what I've defined here is two offsets. One offset describes the first line, one offset describes the second line. So if we look at our code here, and I'm going to draw a diagram so that you really understand what's happening here. I've described the colors. So like the first color is blue, the middle color is red, and then the end color is blue. I've used a linear gradient. I could have used a vertical gradient. I could have used a horizontal gradient. I'm sure you can assume or you can guess that obviously vertical will be top to bottom. Horizontal will be left to right. Linear goes from one corner to the other. So from this corner to that corner. And then these offsets are these describe, what this gradient is going to look like. And I know this is hard to imagine, so I'm going to use a diagram to describe this for you. You guys are so lucky that today you get to see me showcase my drawing skills some more. So let's draw what the phone screen looks like. So here's our phone screen. I know my lines aren't exactly straight, but I think this is good enough to give you an idea. So how would we describe this gradient using the phone screen? Well, first we need a coordinate system. So the origin is up here. On the home screen, this is always the 0, 0 point. We're talking about like a Cartesian coordinate system. If you don't know what a Cartesian coordinate system is, don't worry, it's very simple. It just means that there is an X direction and there is a Y direction. That is a Cartesian coordinate system. So for us, I've drawn the kind of origin Cartesian coordinate system here for you. So the Y direction goes down here and the X direction goes up there. So now that we have our phone screen, we have our coordinate system, we know where the origin is, which is at the 0, 0 point here. How would we describe a gradient using this or in this coordinate system? Well, if we take a look at our code that we wrote here, we have this linear gradient thing. We specified the colors. Okay, that's fine. That doesn't really tell us anything about like the coordinates of where the gradient is going to exist. So there's two offsets here, the start, which is 200 and 200, and then the end, which is 400 and 400. So how does this map to our Cartesian coordinate system? So let me draw our gradient here. So the gradient itself is in red. So imagine that this is all colored in red. And then everything on the outside was blue. So all of this stuff, hopefully I stay in the lines. I'm pretty bad at coloring. I'm excellent at drawing, but I'm not great at coloring. So there's our gradient. That's what it looks like. The red part is the middle. That's the gradient itself. And then the outside is blue. So how can we describe this with 2 points, 2 of those offset values? Well, we know that this has got to be a point. That's got to be a point. That's got to be a point. And that's got to be a point. So we have 4 total points and 2 offsets. Maybe I'll give myself some more room by erasing these so you guys can kind of see better. So this point right here, this circle right here, we'll call this 0, y1. So it's like a variable, 0 and y1. It's 0 because Cartesian coordinate system starts at 0 here, x is in that direction, and y is in that direction. So the x is 0 here, so 0 and y1. That would make this point down here 0 and y2. And then this point here, that would make this x1 and 0. And then this point right here would be x2 and 0. So those are our 4 points that describe our gradient. So because we only have 2 offsets, what that must mean is that the first offset object, it must take x1, comma, y1. And the second offset number 2, would be x2 and y2. So now it kind of makes sense. It makes sense that we can describe this gradient using only 2 objects because the first offset carries x1 and y1. The second one carries x2 and y2. The zeros are assumed because it's going to be right on the axis. So it doesn't matter. That's how we can describe it with only 2 objects, with only 4 points, x1, y1, x2, y2. So if we take a look at our code here, we see that our offset is 200. So that would mean x1 is 200. y1 is 200, x2 is 400, y2 is 400. So if we go to our diagram, I could just write this out for you so you can clearly see what's going on here. That would mean x1 is 200 float, y1 is 200 float, x2 is 400 float, and y2 equals 400 float. And that would describe our gradient in our Cartesian coordinate system. So knowing that, now when we think about this shimmer thing that we're doing, really all we need to do is we need to translate that gradient throughout the screen. So you essentially want to like animate the X1, X2, Y1, Y2 across the screen. And then that's what's going to give us our shimmer animation. That's all we need to do. We really have almost everything we need. All we literally need to do is animate the coordinates. So X1, Y1, X2, Y2. So again, just to remind you of what that shimmer looks like, here it is in the app. We're just translating that gradient essentially from like the origin from 0, 0 all the way down to the bottom corner. That's really all we're doing here. So what I want to do before we actually build like the animation that moves the shimmer or moves the gradient linearly across the screen is just build like a snapshot. Like if you were to freeze time, take a picture of it, I want to build that so that it's not moving. It's just like a frozen in time version of that shimmer. Then we can build on moving it. So first start with like what you want it to look like at any given time, like boom, take a picture, freeze time, and then work on getting that thing to move. So let's go into components and just right click on components, go to new column file and call this shimmer recipe card item. And let's minimize this to give you guys more room. So at composable function, we'll say shimmer recipe card item. We'll open this up. We will need to pass some arguments because of course we're going to be animating this thing later, but for now we're just going to build kind of a frozen in time version like I said. So let's go to our little demo here, our gradient demo, and let me copy everything inside of this because we can reuse some of this. So paste this in. Now the colors that we want to use are not, they're not blue, red, and blue, obviously. I'll actually pass the colors as an argument. So I'll say colors, and this will be a list of colors. So let me grab this. Whoops, I don't need the value identifier up there, and I can get rid of that. This list is actually going to be a list of gray, and then a lighter version of gray, and then gray again, but we'll come to that later. So let's, we can leave this offset. That doesn't really matter. We can have this as the describing or the frozen frame. That's okay. Now I want to add one more argument up here, and this is going to be the image height. So image height, and this will be a float value. Our shimmer animation is going to look like a list item. So taking a look at the shimmer again, we want it to look like a card. Remember, we want this to be like, we want it to look similar to what the list items of the actual recipes do look like. So that's why we're going to add an image height parameter here. This will be the height of the image inside of the card. So inside of our spacer here, I want to fill the maximum size, or sorry, I want to fill the maximum width. So fill max width, but the height, I want it to be that defined size. So write preferred size, or sorry, preferred height, and set that equal to, let's actually call this the card height. Card height, because that's what it is. It's going to be inside of a card. And this should be DP, sorry, not a float. So change that to DP and grab that import. So here's what a frozen frame could look like. Let's go into our recipe list fragment. And up here where we have the gradient demo, let's go shimmer recipe card item and add these colors to the next line, get that to the next line. Now for the colors, I want to do list of, and in the first one, I want to do color dot light gray. And let's do copy and set alpha equal to, let's do 0.9. I think it's a float value. There we go. Now, comma, whoops, comma, go to the next one. We'll do color. Actually, we can just copy that. So just copy that line, press Control D to copy that if you didn't know. I'll change the alpha to 0.2, copy that one more time and change this to 0.9. So this will make it look like it's gray everywhere except for in that sort of gradient area. And let's set a height of 250 dp. So if I run this, let's take a look and see what that looks like. Okay, that's great. That's pretty much what a frozen frame, if you were to like watch the shimmer in real time, freeze time, and look at it, that's what it could look like at any point in time. So now the next step here is moving this thing. How can we get it to like kind of start here and then just animate all the way down to the bottom corner? Well, just like we did in the previous video where I showed you that heart animation, we need to build an animation definition class. So go up into components, create a new package. Call this package, let's call this package util because it doesn't really have a good name that I can think of. Inside of util, go to new column file. You could probably call it animation definitions or something like that. I'm going to leave it as util, but call it whatever you like. Now this class I'm going to call shimmer animation, animation definitions. This shimmer animation definition is going to be a little different than in the previous video when I showed you the heart animation. It's actually not going to be a singleton, but for now, just for simplicity, make it a singleton, and then we'll come back and we're going to change a few things. So every time you make an animation, you always start with an enum class and describe the states. I taught you that in the previous video and also the one before that. So for us, we're just going to have a start and an end state. The start being, when the shimmer starts, and then the end being when the shimmer has completed down in the bottom right-hand corner. So two states, start and end, pretty simple. Now, because the screen width and the screen height are not the same, we need two float keys, or two prop keys to describe the position in the X direction and the position in the Y direction. So if we refer back to our diagram, remember we have these Y coordinates that need to change over time and these X coordinates that need to change over time. The X coordinates and the Y coordinates don't have the same maximum value. They have the same starting value, which is 0, but because you're on a phone, the width is not the same as the height. The aspect ratio is probably like, I don't know, 1.7 or something like that. So the thing I'm trying to describe here is that we can't just translate X the same as we translate Y. We need to track two different values for that. Well, you could actually, but I think the animation just wouldn't look as good. So we'll have two prop keys, one for the X direction. So I'll call it X shimmer prop key and set that equal to a float prop key and give it a label of X shimmer. Copy that and just call this one Y shimmer prop key and give it a label of Y shimmer. Now we can describe, or we can build the transition definition. So value shimmer transition definition. I know that's a long word, but it describes accurately what we're trying to do here. Use the transition definition constructor. We're going to animate the animation state that I have up here. I could actually give that a better name, but it's in the source code already. So, you could probably call this shimmer animation state or something like that. I'll just leave it as animation state because, again, I have that in my source code. Now we need to describe the states within that transition. So state number 1 is going to be the starting state. And I can get that static import to clean that up a little bit. Now open this up, and what does it mean to be in the starting state? Well, we want to do this X shimmer prop key and set that equal to 0. So both of the starting values for the X and the Y will be 0. Remember I said that the values, or the final values, will be different between X and Y, but the starting values both start at the origin. They both start at the point 0, 0 in our coordinate system. So now I'm going to copy that and get the ending state. X shimmer prop key is the same thing, and our end position is now what? How do we get, basically what we need here is we need the screen width, and we also need the height of that card. So now comes a point where we have to transition to not a singleton. We can't use a singleton here because we need parameters. We need things to be passed as constructor arguments. So I'm going to change this to a class, open this up, and add some arguments to the constructor. We'll have private value width pixels, and that'll be a float value. Private value height pixels, and that will also be a float value. Now I'm sure you're like, Mitch, why did you call this or append pixels when this is a float? It's just easier this way. What I'm trying to say is here, this is the width in pixels, but it's being tracked as a float object, I guess. Instead of using pixels here, it's just easier. So this will be the actual width in pixels, but it's going to be a float value. So hopefully that makes sense. So now we come down here and we would use these in the end state. So width pixels, and then this one will be the height pixels. So transition, and the first two arguments here are the states that we're transitioning between. So for us, that's start and then the comma end, and then we can open this up and we specify the two prop keys, or the specifications for the two prop keys. So X shimmer prop key using infinite repeatable, open that up. Add the animation argument. We're going to use a tween so that we can specify an easing. So tween, get that import. So we need duration in milliseconds. That will be the animation duration. How long do we want for this animation? I'll just do 1300 milliseconds to start. Then we want to do delay. So how long, delay milliseconds. How long between each iteration of the animation? Let's just say 300 milliseconds. and then easing, which will be linear easing. So it's not going to change. It's not going to go fast then slow or slow then fast or anything like that. Just one speed the entire animation. And if you're confused about this, I covered this in the last 2 videos on animations. So I encourage you to go check out my animations introduction. I'll put a card up here. There'll be hopefully a link somewhere that you can click and go watch that introduction. And we can specify a repeat mode, even though it doesn't matter. So maybe I won't specify a repeat mode because again, it doesn't matter. The default repeat mode is restart anyway. So now copy this, go to the next line. This will be our Y shimmer prop key, and it's exactly the same. So literally exactly the same as the X shimmer, just rename this to Y shimmer. So this is our definition, our animation definition. We're going to be going from our starting state, which starts the values at the origin, 0, 0, and then we're moving to the width of the screen, and then, or the width of whatever we defined as an argument, and then the height of whatever we defined as an argument. Now let's get started on using this animation definition. Let's go and create a new component. So right click on components, go to new Kotlin file, and call this one loading recipe list shimmer. This will be the composable that we actually use inside of the fragment or wherever you decide to use this shimmer. So annotate this with composable, do function loading recipe list shimmer. Open this up. It's going to take one argument, which will be the image height in DP. So this is how big we want those cards to be in the shimmer. Also add some padding. Let's just do 16 DP of padding by default. So 16.dp. Get that DP import. First, define the card animation definition. So card animation definition. This is the class that we just built. So shimmer animation definitions, then pass the width pixels. So I guess that's another question now. How do we get the maximum width? Well, we can use this composable called with constraints. So let's grab this, cut it, and put it inside with constraints. With constraints, I think we actually went over this in one of the older videos, but it gives you access to like things that are calculated by the screen. So for this, I can say maximum width. So just do dot value, and that'll be a float value. Now do height pixels. This one's a little different. We don't want the maximum height for the card. We want like a predefined height, and that's why I have this image height parameter up here, and then just do dot value to convert that to a float. So there's actually something wrong with this, and I'm going to leave it as it is right now, and we'll come back later and fix it. You know, don't spend too much time trying to figure out what's wrong with this, but just know that something is wrong with this. So when we run it, I'll show you what's wrong and then we'll fix it. It's just a one-line fix, but it's not obvious. I just want to make sure I really highlight that problem when it comes up. Now create the transition, or get the transition from the animation definition. So I'll do card shimmer translate anim and set that equal to the transition and have a constructor, get that import. We need the definition to get from the card animation definition. So just do card animation definition, shimmer transition definition, comma. We need to specify the init state. That's going to be start. And then we need to specify the to state, and that's going to be end. So that's the final state. And we can get some static imports to clean this up. There we go. Okay, so there's our transition. Now we need to kind of specify the colors, so value colors, and then the last thing will be getting the prop keys. So list of, I actually already have this in recipe list fragment, so I can copy this. Just grab this list of and paste it right here. There's our colors, and we have that light gray, so that's what we need for our final product. Now I need to get the float prop key values, or the float values from the prop keys. So value x card shimmer, set that equal to card shimmer translate animation, and as the key do x shimmer prop key. And it's probably right, we need to get that from the definition up here. So card animation definition. So just paste that, do dot card animation definition. So that is the x shimmer prop key. I'll copy that and do y card shimmer, so the y prop key, and then just change this to y. So those are the two values that are going to change over time during our animation. If you want to see those values changing over time, just print a log. So write log d, and you can print these to the log. Just say, you know, y card shimmer, copy that, and do like, or x card shimmer, y card shimmer. You can just do x and do y, and you'll see those changing throughout time through the animation. If you want to see that. If you're like confused, that might be something that helps you out. So now I can use that card item that we built earlier in this video. So shimmer recipe card item, I can specify the colors, and then the card height. So here's the card height. Let's say, 250 dp. But we're not done yet. We can't quite test it. If we look at this Shimmer recipe card item, it has no argument where I can pass the X coordinate and the Y coordinate, the things that are going to change. So we need to go in here and we need to add those as arguments. So I can do X Shimmer. This will be a float value, and Y Shimmer, and this will be another float value. And then we can pass those to our brush. So if we go X Shimmer, we can pass that here, and then Y Shimmer and pass it here and here. So this will not do anything because this will make the gradient so small that you can't see it. So what you want to do is you want to offset these things. We're going to add a bit of a difference. So I'll just do 200 here. So plus 200. So later we're going to refactor this and really kind of optimize it to find like the optimal sort of width of our gradient. 200, I just kind of picked a number randomly out of a hat, but later, like I said, we're going to be optimizing this for like a percentage based width. If you're wondering what this number is, like why I added a difference here, if we look at the diagram, that's going to be like the width from here to here. If you have 0, it's essentially just a line and you wouldn't see anything. So that's why we have to make a difference of this to this. So just so you know, that's what that's from. Okay, now go back to our loading recipe list shimmer. Now this thing will take some float arguments. So we'll have the X coordinate or the X shimmer, set that equal to X card shimmer, and Y shimmer and set that equal to Y card shimmer, and clean this up because this is very ugly. Okay, so now we expect one shimmering card to be in our project. Well, actually, first I have to go to recipe list fragment and also change this to loading recipe list shimmer and then specify a height of 200 dp. Oh, I think this one needs to be the image height. There, that's the last thing. Okay, so now we can just take a look at this and see what it looks like. And like I said, we're going to be optimizing this. I'm going to be refactoring this, and instead of hard coding values here, we're going to like calculate based on percentages what the optimal kind of gradient looks like. All right, so it looks like it kind of almost worked. You can see there's our gradient. Everything's gray. It looks good, sort of, but it's not moving. So what's the problem here? Well, the problem is the thing that I tried to mention earlier, or the thing that I did mention earlier. If we go into, which one was it? Loading recipe list shimmer. It's this right here. So here I'm defining the shimmer animation definition, and this object is getting created inside of the composable. So every time that this is recomposed, this object gets recreated. Well, if this object is recreated and we take a look at our shimmer animation definition, that means that the animation is going to start over. It's going to start in the starting state, and the starting state just has it sitting at 0. So that's why nothing is moving. Every time this is recomposed, or every time a new frame is added to the animation, this object gets recreated. So how can we fix that? Well, we need to kind of bring this over into compose world. So I just cut that. I'm going to write remember, open this up, and then go to the next line and paste it in. That way, basically this object will get ignored whenever it's going to get recomposed. That way it doesn't get recreated. So let's rerun that and see if our animation actually works now. There we go. Okay, so it is actually moving. Of course, this doesn't look right. It's kind of starting in the wrong position. It should be starting kind of off the screen. It's only going to, not even halfway, but it is moving. So we know that we're headed in the right direction. First, let's fix the biggest problem, which is it's not even going to completion. It's kind of going like not even halfway. The reason it's not going to even halfway is because here, this max width value is actually a value in dp. So this is density independent pixels. What we're after is a pixels. If we take a look at the offsets, where did I put the offsets? Here, these offsets, the constructors here, it says they're floats, but these are floats that should be represented by the number of pixels that they're translating. So our problem here is that we're using dp when we should be using pixels, or a value that represents the pixels. So again, we can use another handy dandy Jetpack compose kind of mechanism or function. I'll say value card width in pixels and set that equal to width, do ambient density dot current. This is kind of like the context, but it's the density for doing conversions like dp to pixels, pixels to dp, whatever, that kind of stuff. So now inside here, I want to do max width. So max width, I want to subtract the padding, which I didn't add the padding before, but I want to make sure I do it properly now this time. Let's do max width, subtract the padding, because we're going to have padding at the start and also padding at the end. So we need to make sure that we subtract it on both sides. And now I want to convert this to pixels. So I can just write 2 pixels on the end here. Whoops, I need one more bracket right there. So here I'm taking the width in dp, I'm subtracting the padding, which is also in dp, and then I'm converting it to pixels. And I'll do the same thing for the height. So let's copy this. I'm going to select this, copy it, do card height in pixels, and then we want to do the image height, which will be in dp. Now here I only want to subtract the padding from the top. I don't need to subtract it from the bottom because that's the only thing we care about. It's not going right to the edge of the screen. So now take this card width in pixels, pass it right here, take this card height in pixels and pass it right here. So now we expect if we run the animation, it should look like it's at least starting at 0 and ending at the end. So there we go. We have it starting at 0 and then going to the end. Now the next thing that we can do to refine this is the shimmer shouldn't start on the screen. The shimmer should start at like kind of off the screen and then finish off the screen. So you can see that it's finishing off the screen, but it's not starting off the screen. So we need to add kind of, I guess, an offset for that. So go over into Shimmer Recipe Card Item. And here in the X shimmer, what I want to do is I want to subtract the amount that we're adding. So like the gradient width, and I also want to subtract it here. And instead of adding it to the end, we can just remove this. So I'm just kind of adding it, or I'm subtracting it from the start position and I'm removing it from the end position. So when it starts, it'll start off the screen, but this kind of opens up to another problem now because now it's not going to end off the screen. So let me just run it and I'll show you. So notice that it's starting off the screen. So you can't see it when it starts, but now when it finishes kind of right here. And that's not what we want. And the reason for this is it's no longer, getting that 200 that's getting added to the end. So instead of adding 200 to the offset, which is probably not the right way to look at this, instead what we want to do is we want to extend the range of values that this animation goes through. So we can go to our shimmer animation definition, and here where we have width pixels and height pixels, we want to add something called the gradient width. So let's call it gradient width. And of course, this is going to be red because we don't have this value as an argument, but I want to add it to the width and I want to add it to the height. So let's go up here and let's add another constructor argument here. So private value gradient width, and that'll be a float value. And now this gradient width will be calculated and we can use that to, extend the range of values that the X and the Y go through. And then so that way it'll end off of the screen. So if I wanted to just go into the loading recipe list shimmer, and we're not going to do any calculations yet, I'm just going to do, gradient width and set that equal to 200F because I happen to know that here, I'm hard coding in 200. So I'm just going to put this here for now. And we should see that it is starting off the screen and it's ending off the screen. Again, later, or right after we take a look at this, actually, I'm going to come back and we're going to calculate this value to optimize it to like a percentage-based value. So there we go. That looks way better. You can see it starts off the screen, it ends off the screen. This looks much, much better. So before we do the calculations, I know that earlier I probably did something that is confusing you. So if we go into loading recipe list shimmer, I have this padding argument up here that's 16 dp, and I subtracted some padding here and I subtracted some padding here. But if we take a look at the demo, there's clearly no padding. So why did I do that? That's because in the shimmer recipe card item, I forgot to add that padding in. So let's add a column here and just do modifier equals modifier dot padding, and then just pass that that padding value here. So padding equals should be, we need to add the argument here too. So padding, padding, and this will be a dp value. So now we have that padding passed as an argument. We're actually going to have some padding on this column. This should be, there we go. And then open this up and then put that surface inside of that column. So now there's actually some padding around it. Now let's go to the loading recipe list shimmer. It's going to give me a warning down here because I have that new padding value. So now let's just write padding equals padding. So now there actually will be some padding, and there's a reason, or we're not just, we're not just like subtracting values for nothing. So now let's run this and take a look and see if we can see that padding. Okay, another step in the right direction. Our shimmer animation is starting to look like a real card. We have padding on the outside. It starts off the screen. It ends off the screen. There's a little pause in between. It's looking pretty good. Now, the last thing that I want to do is an improvement that you might even not necessarily find necessary, because this looks fine. But what I want to do is I want to optimize the size of this shimmer gradient based on the screen size. So if we take a look at the diagram again, really what I'm after is I'm looking for a configurable way to set like this distance here, which we could call, I don't know, I'll call this W. So how could we do that? Here, let me scroll down to give you guys some more room, or I'll zoom out a little bit and just so you can kind of see all of this. So how would we define W? Well, it's actually very easy. We would just have the total height of the card itself times whatever percentage we wanted. So we could say W equals, let's say 35%. So we would say 0.35, so 0.35, and then multiply by the total height. And let's call that Y. And that would be our value for W. You know what? I think actually probably 35% is a little big. So let me change that. I don't know. We'll say like 20%. So 0.2. So 20% of the total height of the card. Let's go into the shimmer animation definition, and up at the top, we'll define another value. So I'll say var gradient width. This will be our W value that I was talking about. That'll be a float. Oh, looks like I've already passed it as an argument. Okay, so we can get rid of the argument here. I'm gonna add an init function and say gradient width. So gradient width equals, remember we said 0.2 or 20% times the height. So times the height. And we need to change this to both of these to floats, and there we go. So now we have a gradient width that'll be approximately, or will be 20% of the total height of the card. Now we need to update our other classes, so we can go into the loading recipe list shimmer, and the gradient width argument no longer exists, so I can get rid of that. Also go into the shimmer recipe card, and we need to add a gradient width argument. So gradient width, and this will be a float, and then just add that right here. So here, X shimmer minus 200. Instead, we need to minus the gradient width, and then Y shimmer minus 200. Instead, we need to minus the gradient width. I think we're actually almost done. The last kind of thing that I want to do is we need to add a bunch of these. So currently, like right here, I'm just loading a single one. Oh, this needs an argument still. So this will be gradient width, and set that equal to, we can get that from the animation definition. So card animation definition, and get that gradient width. So as I was saying, currently there's only one card that's showing, but we want to show a whole bunch. So I'm going to cut that. I'm going to add a scrollable column. We don't need to add any modifier or anything like that. Inside here, I'm going to call repeat. This is a Kotlin function that's just going to repeat 5 times. It's like a for loop that's just going to run 5 times. And then I'm going to paste in that shimmer recipe card item. So now let's take a look and see what that looks like. All right, looking good, looking very clean. I think this shimmer animation going horizontally from corner to corner is the best looking one. Of course, if you wanted to change this to go horizontally or vertically, pretty much all you would do is if you go into the, into the shimmer recipe card item, instead of using a linear gradient, just change it to a horizontal gradient, a vertical gradient, whatever you wanted. Now, the last thing I'm going to do here is I'm going to improve this shimmer animation just a little bit. If we take a look at the finished version of the app and we look at like what a recipe card looks like, we have an image, and then down below is a title. So the shimmer, in my opinion, should have like a top shimmer and then a little smaller one. So if I search, you can see that, right? There's like these smaller ones here. This one was the finished version of the app, which has that vertical gradient, which I still need to update. But anyway, just trying to show you what we're going to be doing here. So yeah, let's add a small shimmer that's going to go right below this card. It's pretty easy. It should be only a minute or two that this takes us. So go into the shimmer recipe card item, and here we have a surface and a spacer. I'm going to add another spacer to separate them. So do spacer, do modifier equals modifier dot height, and just do 8 dp. And now below that spacer, copy this one. So copy that surface, paste it down below, get that dp import that I forgot to add. For this one, we want to fill the maximum width, but instead of using the card height, we're going to use a smaller height. So I'm going to do card height divided by 10. So I'll run that one, and let's take a look and see what that looks like. That looks good, but I think a little bit more space needs to be added. So let's add some more spacing. I'll change this to 16 dp and rerun that and take one last look. I think that looks good. I think that shimmer animation looks really, really nice. So now the last thing here is just go into recipe list fragments, and we need to update the code so that this only shows while something is loading. So let's kind of uncomment everything that we have here. I'm going to comment out the loading recipe shimmer. I'm also going to copy it. And inside of this box, what do we need to do? Oh, looks like I forgot one bracket. So inside this box, let's do if we are loading. So if loading, then we want to show that loading recipe list shimmer. And then otherwise, so just else, I want to show our lazy column that we had before, which will just show our list items. I'll leave this circular indeterminate progress bar down below, making sure that it's below everything so that it has a higher priority, so it will essentially sit on top. Remember, we have our box here, and everything at the priority goes from top to bottom, so bottom being the highest priority. So this indeterminate progress bar is going to sit on top of everything else. So let's run this, and hopefully that's it. And we'll be done. Oh, and also maybe go into the view model and change the time it takes for the query, just increase it a little bit. Maybe change this to like 3,000 milliseconds just so we can actually see the shimmer properly. So rerunning that, and let's take a look. Beautiful. See, I think that looks really good. I think that shimmer animation is pretty ideal. Very, very nice. It still shows as you're scrolling, and then there's those list items coming in, 3,000 milliseconds later. Looks nice. All of this stuff is configurable. So if you scroll down, we have like the padding is configurable, the height, how big you want the cards. You could obviously configure the gradient width to like, for us, we're using 20%, which I think looks good. Also like the time for the animation. So here we have, 1300 milliseconds, 300 milliseconds. You could configure these to be whatever you want, play around with these numbers, see what looks better. But generally speaking, that's going to be it. And hopefully this gives you an idea of how you could build other animations like this. I think this animation looks really good. I can't think of any other animation that I would want to use while loading a list. I think this is like the best way to show loading list items. And hopefully I've given you some tools so that you now see, how this stuff is done, where to start. So just to kind of give you a review of like, if you want to build an animation, how do you start? The first thing you want to do is figure out what the thing is you want to animate, and imagine you're freezing it in time and you're going to take a picture of it. What is that going to look like? That's how you want to start. You want to start with like a frozen in time frame of your animation, and then think about how you're going to move that thing around the screen. I guess the second tip I would say is remember the coordinate system. Remember, every screen is just a coordinate system. You have an X direction, you have a Y direction, X goes horizontal, Y goes down. So anything theoretically could be animated to move to any position, any size. It doesn't really matter. Like I said in, I think it was the previous video and the one before that where I showed you the animations introduction. Animations, you can really do anything. I really love the way that Jetpack Compose set this up. You can theoretically animate anything. I really, really like it. If you liked the video, if this video was helpful to you, don't forget your engagement. Don't forget to go down there and turn that little gray thumbs up into a blue thumbs up, meaning that you like the video. Tell YouTube that you like the video. If you followed it this far to the end, this video is probably like, I don't know, probably might even be close to an hour long. If you came this far, you must like the video. So tell YouTube that you like the video. It's very important. Thanks for watching, and as always, I will see you in the next one. Hey, what are you still doing here? The video's over. Well, since you're still here, I guess I'll show you the best Android courses that exist on the planet. I got all kinds of high quality courses. If you scroll on down on the homepage, there's the Jetpack Compose one that you're watching right now. There's that course. We have MVI architecture, if you've ever been curious about that. We have my classic powerful Android apps with Jetpack architecture. This shows you everything from, well, the focus on this one is pretty much database caching. We get data from a real API, we cache it, we basically design an app to work when there's no network connection. That is what this project is all about. We have some UI testing, another UI testing, HILT, which we actually went over in this course. We got clean architecture. This one's probably the best. This is definitely the best course on my website. If you are a professional or you are looking to get into the industry, the skills that you learn in this course are absolutely fundamental. This will give you a big edge in any job environment, whether you're applying or you're already at a job and you want to just improve your skills. This is a really, really, really high quality course. It's hard. Your brain might explode while watching it, but you will learn a lot. You'll learn a lot of really, really fundamental skills. Anything from getting data from the network, caching data, designing different layers, abstracting out the different layers so that you can write unit tests, espresso tests, so UI tests, Dagger, navigation components, everything. It's beautiful. Definitely, this is the best course on the website.